Welcome to the WaterTalk. Very good to see you in this new location. Before we start, I'd like to acknowledge briefly that we're participating today on traditional territories of the Neutral, Anishinaabe, and Haudenosaunee peoples. Our main campus is situated on the Haldeman Tract, as you can see here. Land that was granted to the Six Nations that includes 6 miles on each side of the Grand River, and our active work towards reconciliation takes place across our campuses through research, learning, teaching, and community building, and is centralized within the Indigenous Initiatives Office. We're very happy to have Professor Sathya Gopalakrishnan here with us today. As you can see, she's from the Department of Agriculture, Environmental and Development Economics. So she's a full professor there, and the department's in the College of Food, Agricultural and Environmental Sciences of Ohio State University. Dr. Gopalakrishnan also serves on the faculty of the Environmental Science grad program and is a founding member and former director of the STEAM Factory, a diverse and inclusive grassroots faculty network within the Ohio State community committed to interdisciplinary research, community engagement, and education. Sathya completed her PhD in environmental economics and policy from Duke University in 2010 and then joined Ohio State in 2011. Dr. Gopalakrishnan's research is motivated by an interest in applying economic theory to understand ubiquitous interdependencies between human decisions and geophysical processes in complex resource systems. She works on developing coupled models of complex human natural systems applied to coastal and water resources, non-market valuation of environmental amenities and risks, and resource management problems in which environmental and economic systems are linked by spatial dynamic processes. Sathya finally serves as an associate editor of the American Journal of Agricultural Economics, is an inaugural area editor of the Journal of the Association of Agricultural and Applied Economics, and is a member of the board of directors of the Association of Environmental and Resource Economics. Please give a big round of applause for Sathya, and I'm going to hand over the floor to you.
Thank you so much. Thanks, Roy, for that introduction. Thank you for inviting me here. It's been really nice, and I've never been to Waterloo. I have been to Toronto a couple of times, but never been to Waterloo, and just the little glimpse that I've got is a beautiful campus that you have. So thank you so much for having me. I put this talk together not quite knowing my audience, so I didn't know how many people would be economists or have sort of the intersections with economics, and so I've set the talk up kind of trying to give this a broad overview of how we think about valuing environmental amenities, environmental risks in the context of water resources. Hey, Nandita. So that's that, and I will say, for those of you who are familiar with economics, we usually get interrupted on the slide with questions. So you can ask questions at any time. Please don't hold back, and feel free to interrupt at any time. So the way we think about valuing and what we mean when we try to come up with the economic value of environmental resources, water resources, we're dealing with amenities or resources that don't have markets, where we can't take the prices that we observe for other goods and services that we might buy in stores. But we can think of how markets reveal information about the values that we place on environmental amenities, environmental risks, and use that information to inform how we make trade-offs about where we live, or the kinds of environmental trade-offs that we might make. So markets might reveal information in many different ways. So, and I'm thinking of this in like 3 broad categories. One could be just through the ways in which we observe human behavior, individuals, or it may be firms, and their choices in existing markets, right? So some of those markets might be housing markets. So we see people make choices about where to buy a house, where to live, where to build new housing. Or they might make choices in terms of where to extract resources and what that means for the value of land. Or it might be consumption decisions. What types of goods and services do we buy, and how do those decisions reflect the kinds of value that we place on environmental or non-marketable goods and services, right? So think about buying bottled water as an example. So if you're concerned about water quality, groundwater pollution, bottled water sales can tell us something about what those trade-offs are and how much we value that. And I'll talk about an example relating to bottled water. Another is through the outcomes that we observe in markets. So one is the choices, what people are doing at that micro level. Another is the outcomes that we see. What are prices looking like? To what extent do we see housing prices change? And housing prices can tell us something about the extent to which harmful algal blooms might be impacting a surrounding community, and how far do those impacts go, and how heterogeneous are they, right? Other things could be, do we expect to see changes in demographic patterns? Who gets to live in certain places? Who gets to access ecosystem services, or better water quality versus worse water quality, and so on? So do we see those changes in demographic patterns that can tell us something about the value or the costs of environmental change? We can see that in labor market outcomes as well, right? So what kinds of migration patterns might we observe in terms of getting in and out of certain sectors? So those are outcomes in markets, and of course there are also market-oriented changes that you can see through policy. So policy-driven changes in the outcomes that we might see, and urban sprawl, or the sorts of abatement or incentives that are given for development is a good example of how those incentives lead to certain types of development that have environmental implications, but that also have implications for what those communities, those neighborhoods look like. So these are sort of three broad categories in which we can think about how we can learn from the markets that we do observe and use that information to tell us something about the markets that we do not observe. So a lot of what I'll be talking about today is hopefully of interest to this group, and relating to work around the Great Lakes. And so, the environmental or the environmental stress in the Great Lakes, as we know, is quite high. This is not a group that needs a lot of motivation for this, but just as a quick, the quick statistics, about 84% of the fresh water in North America comes from the Great Lakes. Supports drinking water, about 30% of the Canadian population, 10% of the US population, and there is a long stretch of lakeshore communities that are dependent on these freshwater lakes for a variety of economic activities. And so what we also see happening, of course, is that the quality of the water quality is changing, and this is from Lake Erie. A lot of my work and what the examples I'm going to use will relate to Lake Erie and Lake Erie, the surrounding communities there. But I'm sure you can see parallels with Ontario and the way the issues are going to be somewhat similar, right? So there is, as we know, there's pollution is increasing. About 40% of the lakes are seeing an increase in harmful algal blooms. And again, for this audience, I'm assuming this is going to be fairly straightforward. Water pollution and what happens with harmful algal blooms is you have a lot of runoff that's coming typically from agriculture, but also from increase in impervious surface, for example, through that development and urbanization process, which then gets into the water bodies, affecting dissolved oxygen, which can affect aquatic life, but also leading to microcystin in lake water, which then causes these algal blooms. And when you see that, again, the impact is directly on people who want to be on the lake. So there is the effect on whether you can take your boat out there, fish out there, the quality of aquatic life. Drinking water is affected, and of course, if you're living right by that lake, then how the lake outside your house looks is going to impact your housing value as well. So I'm going to take a couple of examples of applications, and feel free to to stop, or if you want me to go into greater detail. I'm presenting sort of the 30,000 view, but if you want details about data or anything, I'm happy to go there. So we also know that it's only going to get worse. So what we know now, we know it's going to get worse, and because we know it's going to get worse, we need to have good estimates of what those costs of damages are and what the benefits from potentially cleaning up water quality or water pollution will be in different regions. So not only that we want to know what those benefits are, but those benefits are going to be very different across different communities. So the first example is one where we're looking at housing markets. So this is a method of valuation which is called hedonic pricing method, where we're looking at changes in environmental quality and how that's reflected in housing prices, so the outcomes in housing markets. And so this is just from Ohio, where there was a big headline about algal blooms can cost homeowners up to $152 million over a long time period. And there's a lot of investment in water quality and in improving water quality in Lake Erie, and this is and all the Great Lakes, really. So what we do here is in this particular study, we're looking at Lake Erie and really concentrating on that western basin. We look at housing transactions in all of these counties that are adjacent, that are right around Lake Erie, and we collect data from 2003 to 2015 on all the sales transactions. And so when we get data on housing sales, we also get information on how much the house was sold for and the characteristics of the house that was sold, like how many bedrooms, what's the square footage, whether it has a garage, a basement, all of that information. And then we link that with information about algal blooms. So in this case, we think about chlorophyll A as an example of what reflects the likelihood of a bloom, or the extent to which you might that would translate into clarity for positive water quality or pollution. And so we look at single-family homes, sales of single-family homes located within 1.2 kilometers. I'll get to why we choose 1.2 kilometers. And we're looking at two attributes. One is algal concentration, and also the detection of E. coli, right? And in a different study, we'll talk about why those might be different, and different groups of individuals might value contamination from E. coli differently from algae. So the price of a house really represents the value associated with a whole bundle of attributes, right? So you might think of how you pay for a house, you pay for a number of services. That could be the number of bedrooms you might have, the number of the overall square footage, and what services does that structure provide you. You might also be concerned about what is going on in the neighborhood, right? I want to live, and school quality is a big one. We choose where to live based on the quality of schools, safety, so crime rates in a neighborhood, and so on and so forth. And then we're interested in the environmental aspects. So the way we do these analyses is we look at a number of transactions, usually in the hundreds of thousands, and we control for all of these different types of attributes, and then we try to isolate what that marginal value, what is the implicit price that we pay for water quality. In this case, it might be air quality, open space, or whichever environmental amenity that we might be interested in. So I talked a little bit about that 1.2 kilometer. So what we do here in this particular analysis, just a little bit of technical detail, we try to do something that is non-parametric. We use sort of a functional form to determine how far from the lake does the impact of water quality really stretch. And we do that by looking at a large, by looking at observations. I think we have close to 132,000 observations over that time period, and we try to remove everything other than proximity to to Great Lake. So we control to Lake Erie. So we control for everything else, and we're left with a residual, and that explains the distance to the lake. And that's the only thing that's remaining. And we look at what point does that distance stop mattering, right? At what point does distance not matter anymore? And then we cut off our analysis at that 1.2 kilometers. And so what we find here is that there is heterogeneity in the impact of algal blooms, and we see that this effect sort of dissipates both over time and over space. So we look at, if we take the presence and the concentration of algae measured within 6 months prior to when the house was sold, we see that a 1% increase in algae over that 6-month time period leads to an 11% decrease in housing values. If we increase that lag and take a 12-month lagged measure of highest observed algal concentration, that effect goes down to 8%. And if we go to an 18-month lag, then we don't see any effect. So it's a short term. When the bloom is there, if you see housing sales, it picks up that discount. Similarly, over space, right? So we look at what happens to homes that are within 300 meters. The discount from a large algal bloom could be as much as 13%. As you start moving farther away, and when you hit that 1,200 meters, we see no effect, right? So what this tells us is something about what that incremental value or the cost of water pollution is, and how far it ranges, so that policies can be targeted if you want to invest in a water quality fund, or having taxes that are associated that go towards improving water quality and so on. So that's one kind of market outcome that we can study. Another study, and this one's looking at groundwater and groundwater risks that are associated with shale gas exploration, right? And so this is looking at what happens in Pennsylvania and Ohio. At the time around that 2007 to 2010 is when shale exploration was going on in Pennsylvania, hadn't started in Ohio at that time. And one of the biggest concerns was that when you drill down for subsurface natural gas, you tend to affect water quality. And there was a lot of talk about, you open the tap and water catching fire and all that kind of. It was the early days. It was pretty bad. And so in this study, this is one that some colleagues at Ohio State have done. What we can look at is, first, how much are people concerned? This is a Google Trends map. And so you look at just the search for shale, and as the exploration activity goes up, you can see Pennsylvania, people searching shale and anything related to shale just spikes. And on this panel here is the amount spent, so expenditures on bottled water. So people getting concerned about drinking water quality. And you can see here that this is Ohio. Ohioans were buying more bottled water relative to Pennsylvania. And then you can see this shift happen as shale started becoming a concern, right? And so again, this is another type of market that we can use to back out how much people care about water quality. Yeah.
So I was thinking about the awareness and with regards to the algae, and you mentioned it here with the shale, but it's odd that people would be aware or that impact is just right close to when the event happens. Whereas if people are aware, it's a recurring thing that you would think that should be more a long-term effect. So I found that curious. So maybe they're not. Maybe that's not in the real estate news. That this is something that happens, or
it doesn't. So I think what we've noticed with algae is that people react when they see warnings. Actually, what in one of the studies, we look at the effect of the concentration, because you don't know how much algae there is unless it looks bad, unless you can see the green. It's not something that people even know is a problem, and it's not. And you might think, yeah, there is the problem of algal blooms, but there is also the idea that it comes and goes, and it may not be so bad throughout the year. And so, what we see is that the presence versus the extensive margin of whether it's there or not tends to drive a lot of the price effect, and then how much is relatively a lesser lever in terms of how it affects prices.
Sort of how often?
How often? Yeah, it happens almost every year. It's almost every summer. And so I don't think people have done I haven't seen a good study of this expectation story, which is I think what you're getting at. If people expect that there is going to be water quality is getting worse, does that expectation sort of show up in a declining price trend? We definitely don't see that in the housing market. We don't see a trend where environmental risk is sort of systematically leading to this declining trend. We don't see this in water quality. We don't see it in other work that I've done. We don't see it with coastal risk either. And that's even more striking. We see that oceanfront and coastal housing or counties along the coast tend to have a high premium regardless of more hazards, big storms, and you still see housing prices go up. I do have a theory for that, which is the investment in relief. So it's there's a strong correlation, and it can be explained by how FEMA assistance in the U.S. is provided, which kind of tends to dampen the signal of what we observe. So in the coastal risk situation, I think it's a very clear policies or subsidies that are storm recovery or restoration activity tends to dampen the sea level rise and the chronic stress signals by a large extent. And I think it's similar with water quality. If there's a lot of state level funding that's going into maintaining our water treatment and so on, so I think that's a similar policy induced dampening of the effect, which is probably why we don't see that expectation story. Other questions? So this one is a study where you can get. So one of the things with data, again, there are certain types of consumption data that are easy to get. Like you can get grocery store data at that zip code level, like how much do people spend in any given week on bottled water. So you can use all of that information at a fairly fine spatial scale and look at proximity to where shale activity is going on and compare differences in the change in prices in two different locations, one that had shale activity, one that did not have shale activity over that time period. Right, and so that's and this type of valuation is called is averting expenditure. So you're using how much are people spending to avert or to avoid or to mitigate the potential risk, and use that as a way to inform what their values are. A third is looking at recreational markets, right? So markets for recreation and where people go to swim or to fish and so on. And this is also going back to Lake Erie again. This is a study again in the similar part of Lake Erie. And what we did here is this is a survey-based method where we ask people how much do you spend? What is the travel? What is the cost of traveling to a particular site? And so what we do here is what's sort of interesting in this study is we look at the simultaneous effect of algae and E. coli, and whether those effects are different for different groups of resource users. So we send out a survey to a number of people, 20,000 households in Ohio. We didn't have a great response rate, but we were still able to capture a lot of that heterogeneity. And one of the things that we ask people is, did you notice an advisory? So going back to whether there was one of those strong signals saying, don't go into the water, don't swim, don't drink type of advisories. And we use a way of using factor analysis, which I think is used in many different disciplines. It's not an economic specific method. We use factor analysis to sort of look at who our respondents are and try to identify groups of respondents as people who care about the fishing and getting into the water, who we call, anglers, and people who go to visit the beach, picnics or just going out and spending a day with friends on the beach. And so we're trying to get to that underlying motivation for what determines what sites you go to on a particular day. So this is, all of these dots represent the homes that we sent out our surveys to. Again, these are counties that are adjacent to Lake Erie. And then we have along the lake, we have these triangles which represents the access sites. So we ask people, did you take a recreational trip? And if so, where did you go? Which of these sites did you go to? And so this is what we used for the factor analysis. We asked them, what is the primary purpose of your trip? And then we use that primary purpose to sort of to kind of use a data-driven way to group people into whether they are beachgoers or whether they are anglers. And what we find is that fishing costs, or anglers tend to spend about their cost an additional $21 to reach their preferred site for recreation relative to a beachgoer. And no surprise, beachgoers are more sensitive to changes in E. coli, whereas anglers are more sensitive to changes in algal concentration. And then we use what we find from this sort of latent class analysis, and it's again the way these models are done are looking at, did you go to a site or not, and how can we explain someone's binary choice of where they go. So it's a nested approach. Do you take a recreational trip or not? If you take a recreational trip, where do you go? So it's that site choice that we're trying to explain. And once we're able to get that marginal willingness to pay, which is the incremental cost that you're willing to incur to get to a particular site, to get to a site which has lower pollution than another site. And then we can use that to do a number of different simulations, right? So we can say what would happen. In the paper, we have 5 different policy situations that we analyze. But one could be an extreme, like what if you had to just close off all the sites, if you had to close off all these Western Lake Erie sites, right? So then what we find is that the per trip cost to anglers could be, the per trip increase in cost could be up to like $23 for anglers, about $2.3 for beachgoers, but that when you add up across the number of trips that different visitors take, that can be a pretty big number, like over $70 million for 1 year if you had to close the entire, that part of the lake for a year. So these are sort of just 3 flavors of how we might think about valuation, and 3 different types of data that you can use to get at similar values of water pollution. Why does all this matter? Of course, we care about what happens with environmental quality and how we can measure that. One of the sticky points or things that might be harder to do is to look at how welfare or people's well-being, or how we can calculate those benefits and costs, can be done for non-marginal, like really large changes. So all of this is what happens if there's a 1% increase, a 1 unit increase, and what happens when you're just sort of moving a little bit around that equilibrium or the mean level that we observe. But what if we could then start thinking about these large changes and go from just saying it's worth $1 or 1 point to actually being able to get something like the slope of a demand curve. How does that demand function look like as environmental quality changes? How much more are people willing to pay on the margin? And that can then help us connect with geophysical models, typically hydrological models, of what can we say if in the future this is going to be the change, and how do we then plug in a function that can help us determine what would be optimal? Where do you invest? How much do you invest? And when do you invest more in water quality. And what we find, and this is a more technical paper, so I don't think I'll get into the details, but what we find is that, one, initial conditions matter, and that there's a lot of spatial heterogeneity. So I'll talk a little bit about what that bias is and why we want to think about stepping beyond just that point, which is that marginal cost at a single point, to trying to get to that slope of a demand curve. It's really this area that we're missing out. It's kind of a, if you think about water quality and how much people are willing to pay for water quality, as the quality gets better and better, the incremental amount that someone was willing to pay would be going down, and that's a typical demand curve. So if you think of a demand curve that looks like this, and what we estimate is a point where you say this is the mean level, and for a lake that has a mean level of algae at a certain point, we can get that marginal willingness, marginal price or marginal cost using either housing prices, using a variety of different data that we can get. And that will tell you that this is the marginal price, the implicit price of water quality, at a mean level of water quality. We're really measuring it at that mean. And if you take that and say we want to increase or decrease water quality from Q1 to Q2, that is a large change in water quality, if we only have this point, the total value that we would estimate is probably this rectangle. We'll say this is the value, this is the reduction, so it's price times quantity, right? When what we actually want is this area under that curve, right? So and of course, that bias depends on whether you're, what that slope is. So if it's a very steep curve, then that bias is higher. If it's a relatively flat demand, that's going to be lower. So we've tried to sort of just make a first move in that direction, and we're using housing data, and we're looking in this case at inland lakes in Wisconsin, and we're looking at 23 counties where you have inland lakes that are running through them. And what we do is actually building on that first step that I talked about, which is that hedonic pricing. We look here at water clarity measured by Secchi disk depth. And this is just showing like there is a lot of variation at the county level over time in terms of that minimum clarity that we can get. So we're using this variation in Secchi disk depth, and we're using housing transactions. We're looking at a number of housing transactions over again that I think this is also in that 2000 to 2015 data. We also get demographic information using the Housing Mortgage Disclosure Act. What are the loans that people take? What is the income level that we can get from there? Information on household characteristics. And then we look at housing markets. We look at different markets, and we use variation across markets. So what we did, what I showed you first was what's happening in Lake Erie, just those counties right around in the Cleveland area, for example. If you can look at these counties as being separate markets, you can then look at not just what's happening in one market, but use variation across these markets to back out what might that function look like. And so just a flavor, I don't think I'll go into what these data look like, but these are the sorts of data that we get. How much do people pay? What is, all the characteristics of the house, how close is it to the lake, distance to a boat ramp, and so on. So we get all of this information. We estimate a model that looks like this, right? Log of housing prices as a function of all of these attributes, particularly looking at water clarity and looking at number of housing attributes. We control for which month, which year, and so on and so forth. We get that implicit price we talked about. We estimate that for the 27 different markets. And then we use those 27 prices to then look at variation across demand characteristics or household characteristics to then start getting a lower bound estimate for what that slope would be. So this is just the way we do it. The details are probably a little more technical, but I do have some extra slides if anyone's interested. And so I'll sort of wrap up by sort of saying, okay, why does all this matter, right? Like if we can get at a reliable number or a functional form even better, we can then start asking questions about what should optimal policies look like. And this is really new work and things that are still ongoing. So I don't have a whole lot over here, but what we're trying to do is model this in a numerical, first in a sort of simulated landscape, and say if you had different farms which have different kinds of soil quality, darker green, maybe better soil quality, and soil quality might be, one example could be the nutrient absorptive capacity of that soil. And you can take that farm level information, distance to the lake, and then think about what might be active policies, which could be a fertilizer tax, for example, and how would that impact water quality and what might be the benefits that you get. So is there an optimal way to spatially target policies? So that's what we would do in this case is you'd develop an empirically grounded model by linking some sort of simplified measure of the hydrology without having it without having to use a whole lot of parameters. But if we could rely on a few key leading parameters and something that says what the absorptive capacity is, something that talks about the distance to the lake, and use that to then think about, are there welfare gains from spatially targeted policies? And this is in the sense of how there is a lot of interest in precision ag. So how precise do we want to get at that farm level, at the acre level? And so what we're trying to do is, in an entirely simulated world, if we could get more and more and more heterogeneous, so more precision, is there even a cost to that? Is there an optimal level of precision? And these are super preliminary. So what we do is we kind of divide the landscape into, and we've done this for 20 different types. If you had to go to 20 types of targeted policies, and your policies are heterogeneous based on the characteristics of the farm, we see that welfare gains tend to increase as you increase precision, and at some point the incremental gains that you get start going down. So there might be, where this is headed, or where we're trying to go with this, is trying to see whether there are some optimal levels of spatial targeting that give us the highest bang for your buck in terms of precision ag. So that's one direction that I think would be really fun to work in these coupled models. Another that I thought might be of interest to the Greater Toronto Area people would be to think about the supply of housing, which I haven't talked about at all. But where is new housing being built? And I know that is, it's definitely a topic of interest in this area, which is growing really fast. So this is a study which I was not involved in. This is not one of my studies, but this is looking at the Baltimore area. And what they do here is these red areas are parcels which can be developed. And so they're looking at can you predict what influences development, where you're going to go build another home, build infrastructure. And then you can connect that development decision with hydrologic models that look at how increase or changes in impervious surface can affect water quality. So then you can start asking these interesting questions about, are there trade-offs in terms of if you were to tax certain types of development, so these leapfrog developments where you start developing farther away from a municipal boundary, which means you might need a septic tank, you might need different sorts of sewer infrastructure and so on. And if you tax that, then it's possible that you might reduce overall nutrient runoff because those taxes will disincentivize development. But then that might also lead to conversion of some forests into vacant lands, or forests and vacant lands that used to serve as buffers. And so you might see this trade-off in terms of where that conversion happens, and you might increase. Because of the loss of these buffers, the increase in impervious surface area can lead to lower water quality, even though it was intended to have the opposite effect. And you can think of the same thing with policies that are like the Greenbelt policy here, right? About where you can and cannot develop, having those sort of spillover effects in terms of what the short-term versus the long-term adaptability of that region might be, right? So those are questions that you can start asking by looking at where we can connect these decisions that are economic decisions of when to build and how much these prices, well, what is the housing price, to what these changes mean for environmental outcomes. So I'll stop there for questions. Thank you.
Thank you very much.
Thanks so much, Sathya. I was just looking behind to see if there's any students, so then I wouldn't talk, but I don't see any hands, so I'll start. And that was a fascinating talk. I learned a lot. I had a question about your relationship, and I'm talking about a space that I don't know anything about, so about the price versus the degradation of the water quality, and the idea that as the water quality gets worse, people are willing to pay more. And you alluded briefly to the initial condition effect. So my question is whether the relationship in reality is really that, or whether, so this is more anecdotal than scientific, right? So when I talk to people around here about Lake Erie and algal blooms, it's like, people living here for 30, 40 years, we've seen algal blooms, whatever. I mean, it's Lake Erie, it will always have algal blooms. So if it gets worse, what does it matter? Versus if I'm talking about the northern lakes where I go have a cottage, there an algal bloom matters because I didn't grow up seeing that. So I feel almost, it's like there is a threshold, which is a very early threshold, whereas it gets worse, people care about it. And then it not only plateaus, it probably changes, decreases, because at that point I've crossed that threshold and it doesn't matter to me.
That's a great point. I don't know that we. I think what would be really interesting is to try and like empirically identify where that threshold is. So what we can say from the economic or from the housing data is that the presence and absence makes a big difference. So you might, if you're going to this pristine lake where there is, where it's clear waters, you can see you can see through, and it's great. That to having any algae is a bigger jump in change in pricing relative to one where it's getting little worse to more worse. That we definitely see, and that's where those initial conditions do tend to matter. And the way we think about that is when we're looking at multiple markets, what the baseline is, or we look at baseline as the mean that you might observe over a longer time period. That tends to drive what that marginal price would be, and in that analysis, or in doing something like that, the jump from what we would call the extensive margin from not having an algal bloom to having an algal bloom is much higher. And I think that would get to this. But I don't know if there have been studies that actually map out what that threshold is.
Thank you. That's very fast. So can I ask a follow-up in that? So part of one of the things, and this is the relation to your shale gas, where there was an immediate effect. So again, substitutable goods versus not. So if there's an algal bloom, I just go to a different place. But if my groundwater is polluted, that's when I have an immediate. So I feel like that kind of behavior is probably more like, changes more dramatically at the more polluted end for.
Yeah, and it changes over a much shorter time period. For sure. Yep.
Yes, I was just wondering if you could talk a little bit more about the cost of more precision, what's causing that to be less of a welfare gain as you get more precise with measurement and so on.
The way we do this, I mean, it's kind of model dependent as well. So we have a cost of implementing a policy, and that comes from if you have to actually measure. So you have to go there and divide up the existing landscape into X number of zones. That would incur like a fixed cost, and we actually in the model, that is, we're increasing the cost of implementing a policy as the level of precision goes up, and that could come from investment in certain types of mechanism, or just the sort of regulatory cost of having land assessments to know what the soil quality and the potential contribution to the damages might be. So we use in that particular study, we're using a hydrologic model to kind of inform that. We're using what are called, and not my area of specialty, hydrologic response units as being sort of the landscape where we're saying everything here contributes to pollution in a certain way, and so how can we use that combined with distance? So it is a cost of implementation driven change, whereas the benefits kind of keep increasing, but you do have declining marginal benefits, and so that shows up from what is the incremental gain that you will get as reflected in the runoffs that can be predicted. Does that answer your question?
I think
so. We hear the cost of monitoring, and there's so much. It's so much easier to monitor, and at the agricultural level, and so that the cost is going.
It is
seems to be
going
going down. So I guess it becomes an empirical question.
It is an empirical question, and I don't know how much those economies of scale are yet. So we're still sort of playing with what those parameters should be. Got it. Yeah. So that particular study is looking only at surface water, lake water. That's an algal blooms study. So I'll just add two things that could have been confusing in all of this. Each type of water use is going to have a different market that's associated with it. So the bias in this particular case is coming only from housing market responses. So we would not be able to do that analysis where we would capture housing market responses and, say, bottled water market responses in that same analysis. So we wouldn't be able to look at, it would be hard to look at the substitutions that way, because the value that you're getting is different. So that particular analysis is based only on looking at housing market capitalized changes, and the bias really depends on whether you're capturing the point on that demand curve where the incremental value is high or low, right? So that slope is what we were trying to get at, which is only looking at the housing market. So as different sources of water go up, right, you'll be looking at different markets, and I think there might be changes in what that slope would be for attributes of water quality that have better substitutes. And so you'll only look at that particular attribute, which might be drinking water in this case, and the quality of substitutes getting better. You'll expect it to be flatter relative to something where those substitutes aren't getting better. Does that answer your question? I think, so this is not work that I have done. I think, so in the kind of survey work that we did, we tried to get look at heterogeneity by demographic in terms of age and education were the two main sort of levers we were trying to look at, and we did see some variation in how much people cared about water quality and their recreational choice. One of the big signals were whether our respondents were households with kids or not. So that having kids, households with kids tended to be more risk averse for sure, and cared a lot more about that E. coli issue, and that definitely showed up. So that's the heterogeneity we were able to explore. Now there is work more broadly on just risk perceptions around climate change, where there are people looking at how are perceptions changing. I don't know that there has been any systematic economic study on whether that base level of risk has changed or not, simply because you're often relying on a shorter time frame of data. I don't know that we have data over, we'd need at least a few decades to start observing generational differences. But I know that there are studies both in political science and sociology where they look at, the internet generation versus not the internet generation, and I think those effects are significant in terms of how much information is out there. The only extent to which I have used some of that information is looking at how much something appears in the news, and news being as local as possible, so you can get at how many times was something put in the local newspaper website. So you can scrape all of that information much more easily now, and so that's something we do. We do sort of look at what is the information exposure, but I'm not aware of any. Well, I don't know if there are any that look at that baseline change, but I'm sure someone's working on it. If not, that's a good question to work on. That's a great question. So I'll say that this analysis is sort of our how it's our pilot simulation to see what we can take to data. So in this particular study, we only looked at fertilizer tax, which, even as a starting case, is one of the least feasible policies in the US. It is not something that will happen in the near future. But we took that as, because a fertilizer tax is, from an economic standpoint, a fairly efficient strategy, we looked at the precision or the heterogeneity is how different, like how would you vary the tax by the characteristics of the farm, at a farm level characteristics. So that's the heterogeneity we're looking at. Now there is some ongoing work which one of my students is working on, where they're looking at a suite of conservation practices, and that includes buffer strips, type of tillage, the crop patterns as well. And those are just 3, and there are a few more. And they're looking for in that study. Her study is on land-based carbon capture, and so she's trying to do at that pixel level, which is a farm level characteristic. Is there a combination of strategies, which is how much would you put in conservation tillage, how much would you have for buffer or cover crop, and can you kind of map out a landscape? And she's also looking at the Ohio Lake Erie, the Maumee River Basin, and so you're trying to see if you can really have what that optimal portfolio would look like for the entire region. Now that's a much more computationally intense project, and right now she's working with the EPIC model to try and get the soil characteristics, and is still at the process of just trying to map land use into the EPIC model. But that's then the next step would be to see if we can get to what you're suggesting. Thanks. I'll respond with just a couple of quick comments. I don't think I can. I don't know much or anything at all about precision agriculture to go into any detail in responding to that to your question or your comment. But if anything, what we're trying to do, and this is why we're not using empirical data to be able to do this yet. But if anything, what we're finding is a little bit of caution, which is you can't push this too far. Is really what we find. There is value to understanding the micro level heterogeneous effects, and that's what we're getting at. But the more and more you try to do it, the value goes down. It's not really going to keep being helpful. It's not going to help in any way to solve, even if there is a bigger social cost issue. So that is kind of the initial, very preliminary finding that we're getting at. The second part of it, in terms of pricing water, I didn't get into into the distributional impacts at all, because that is a huge issue and could be its own hour if we had to start thinking about what the distributional implications are. What I will say in this is it's not about pricing the, nothing that I have talked about or what we're doing in these studies is about the price that you have to pay to buy, for your drinking water. I agree that that's a big issue, and I think, the right to clean drinking water is and should be a right. But what it tells is a bigger story of, in all of these valuation methods, and if I were to go into a little, into just a critical view of the valuation analysis itself, everything that we're looking at is coming from a willingness to pay, right? What are people doing? Are they moving? Are they moving to locations that are less polluted? Are they buying water, and are they doing these things? All of that is ultimately conditional on income, right? It is stratified by a constraint, which is how much are you able to pay? So this idea that somehow it's a choice whether you want to get higher quality or access to ecosystem services or live near a lake and so on and so forth are not quite the choices as we think of them as choices people can make, because it is very much, and demand is income dependent, so it is very much a conditional on the distribution of income. So that's just a word of caution for all types of valuation studies, that it starts with whatever the baseline income distribution is.
Applause.
Thank you.